Welcome back. Today's lesson is going to deal with factoring, something that we've done in Chapter 5, but we're going to revisit that skill and elaborate on it. We are going to sometimes have four terms in which we will factor by grouping. And then there might be times when we have a degree greater than 2 in our polynomial, and we need to learn how to break that down. We already know how to factor out a common monomial, but this will be a little bit more expanded in terms of the degree of the exponent once again. And finally, we're going to learn how to factor completely. We are going to use an MAF box to factor by grouping, and you're going to love the idea because it's going to make this problem so easy. But let's make sure you understood the basics. The 6x squared goes in the first box here, that's the first term. The 5 goes in the last box in the lower right hand corner. As for the other two boxes that you see empty right now, we'll fill them with factors of 30 that add to a negative 13x. Now in order for me to get a positive 30, yet a negative in the middle, I'm going to have a double negative. Factors of 30 are 1, 30. I also have factors of perhaps a negative 2, negative 15, and how about a negative 3 and a negative 10? We're going to ask ourselves which one of those adds up to a negative 13 when we put them together, and we discover that that would be the negative 3, negative 10. So those are the factors that I'm going to put inside the other two squares, so negative 3x, negative 10x. Remember that if the sign is next to where we're taking out the GCF, that is the sign that comes out. So since that 10 is negative, a negative will come out, and 5 and 10 have a 5 in common. The 6 is positive, so we'll keep it positive, and 3 is the highest number that goes into both, and we also need an x. That's a GCF on that one. We have a positive 6, so we're going to keep it positive. What's the number that goes into 6 and 10? 2 is the answer, and don't forget to bring along the x with that. And finally, since the 3 is negative, we'll have a negative, nothing else in common but a 1. Final answer for this would be the factors are going to be 3x minus 5. So you'll see that I went ahead and took the row at the top, and now I'll take this column to create my second factor, which is 2x minus 1. So keep this in mind. We are going to use MAF skills to factor by grouping. Factoring by grouping is extremely easy if you just use the MAF box, and notice that we have 1, 2, 3, 4 terms. Whenever we factor by grouping, we will have 4 terms. We have 4 boxes. So that's going to make it really easy for us because we really technically don't have to do the master product and the add-in because we already have the problem split up ready to go. So I'm still going to use the same process where the first term goes in the first box and the last term goes in the last box. As for the other two terms, we're just going to put them in the remaining boxes that we have. Now all that's left for me to do is to find the GCF. I'll notice that we have an A and an A in the first column, and so I'm going to take out an A. In the next column, I have an X and an X in common, so I will take out an X. And this is how easy it is. What do we have in the row? We have the Y and the Y, so we'll take out a Y. And as for the last row, they both have a B and a B in common. All that's left for me to do is to write the factors. My factors are going to be X plus A, Y plus B. And that's all there is to it. Let's go ahead and try another example. Example 2 is, again, the same situation. We have 1, 2, 3, 4. So I'm going to go ahead and create an MAF box. I don't need to do the master product. I just need to fill in all the squares with 1 term each. Really doesn't matter where you put the terms. Just make sure every box gets a term. Don't forget to take the sign that's in front. And now all that's left for me to do is to find out what the GCF is for every single row or column. In our first one, we know that this is negative, so we're taking the negative out. And the next thing that they have in common are the b's. So it's going to be a negative b. In our next column, we have an a in common. Taking care of the first row across, we have an a in common. And finally, in the very last row, we have a 2c. That would mean that our final answer is going to be a plus 2c, a minus b. Here's a factor by grouping for you to try. You have your 4 terms, set them up in your MAF box, take out your GCF, see how you do. Well, welcome back. How'd you do with that problem? You got it right if you have a plus b and r plus 5. Remember, it doesn't matter if you have a plus b, r plus 5, or r plus 5 times a plus b. They're the same answer. We're going to be factoring polynomials in quadratic form. And if you'll observe in example 1, we have a power greater than 2. It's actually a 4. And for that reason, I would like to recap a very basic skill that you just learned, making sure you understand that if we have x squared times x squared, it will result in an x to the 4th because we add the exponents. So that would make x to the 4th times x to the 4th, x to the 8th. Taking it one step further, how would you break down an x to the 10th power? Finding out a number times itself that would give us x to the 10th would be x to the 5th, because x to the 5th times x to the 5th gives us x to the 10th. So let's see how we incorporate this in example 1. I have 3. I have a trinomial, so I'm going to use my MAF box. My master product is 2 times 1 or 2. And my added, notice, is 3x squared. That's a little bit different for us. So we are going to find factors of 2, and of course we only have 2 of them, the 1 and the 2. And those will both be x squared since I have to come up with 3x squared. Watch how this works out for us. If I have x to the 4th up here, put my 2 in the lower box, and I have x squared and 2x squared, my GCF will be a 2. Over here, what's the GCF? What's the lowest you have? We have an x and an x here. We have 4 x's over here. So the GCF are 2, so x squared. Same thing for the row across. I have an x squared in common. And my GCF in the last row is simply going to be a 1. Therefore, my answer for this problem, or my factors, are x squared plus 2 and x squared plus 1. In my second example, I only have 2 terms. What do we know when we have 2 terms? First thing we have to look for is a GCF. If I don't have a GCF, the second thing I look for is a difference of squares. So here we go, looking for a GCF because I have 2 terms, and I'll notice that they both have a 2 in common and they both have a c in common. So that means I'll be taking out a GCF of 2c, leaving behind, or I can simply divide by 2c, and I would get c to the 4th minus 25. Now I have to see if I can break this down even further. Is c to the 4th a perfect square? The answer to that is yes, because c to the 2nd times c to the 2nd gives me c to the 4th. And of course the 25 breaks down to 5 times 5. When I do a difference of squares, I have a positive quantity and a negative quantity. So I'm going to fill this in with a c squared plus 5 and a c squared minus 5. Now because I have powers of 2, I'm going to look to see if I can break these down anymore. The c squared is a perfect square, but I have a plus sign. When you have a plus sign, you are done with the problem. You cannot break it down anymore. Over here I do have a subtraction sign, so maybe it's a difference of squares. The c squared is a perfect square. However, the 5 is not a perfect square. Therefore, my final answer is simply going to be the 2c times c squared plus 5, c squared minus 5. Now in this slide you can see we have to factor completely. You're going to see what that means real soon. It simply means make sure you have broken this down as far as you can. So never walk away from the problem until you have looked to make sure it cannot be broken down anymore. So we've got 4 terms here in this particular polynomial. And so if I have 4 terms and it's not a trinomial, I am simply going to write the x to the 3rd in this box. And I'm going to fill in the 18 here. And since we've already done problems like this in this particular video, I'm assuming you're following along quickly with me. I'm taking out that negative 9. I'm taking out an x squared. I'm taking out an x and a negative 2. So I think my answer is x squared minus 9 and x minus 2. But here's where the caution comes in. As soon as you have a square that is in your factor, you must look to see if you can break this down more. So you need to look to factor more. And so we have to say to ourselves, all right, I only have 2 terms. What with 2 terms can I ever use to break things down? And I hope what comes to mind is difference of squares, because I can break down that x squared and I can break down that 9 to an x and a 3. And I always know when I don't have a middle term that I'm going to do an x plus 3, an x minus 3. I already had the x minus 2 there already. And so this is now factored completely. So once again, I want to reiterate, look at your factors. If you have anything higher than a degree of 1, look to see if you can break it down more. Here's a problem for you to factor completely. You have 4 terms. Think about what skill you want to use. Also, remember to factor completely means to look at all your squared terms and your factors and see if they can be broken down any further. Go ahead and press that pause key, figure it out, come on back when you're finished. Well, welcome back. The answer to this problem is y minus 3, x plus 2, x minus 2. If you have an x squared minus 4 in your answer, you need to break it down even further by using the difference of squares. Alright, so let's always look for the GCF when we are factoring. And when it comes to using that MAF, you'll use it when you have 4 terms, or if you have a power of 4 in your quadratic. And the difference of squares does not use an MAF. Just go ahead and break that down to a quantity that has a plus sign and a quantity that has a minus sign. Don't forget when you're in the difference of squares, look to see if you can factor that completely. If the degree is greater than 1 in any of your factors, look to factor it more. Break it down even more. All right, that concludes and wraps up our extended or elaborate factoring.